Hello, good morning all. I am Dr. Uttra Chandrawat from Government College Kota, and we are going through the chapter of polymers in the fourth semester for the inorganic specialization. So in the past lecture we went through the classification of polymers based on the mechanism that by which mechanism they have been formed. So we learned that the condensation polymers जो हैं, they are usually formed by the stepwise intermolecular condensation of reactive groups, while addition polymers, they are formed from the result from chain reactions involving some sort of active center. That is, in other words, we can say that these polymers, step reaction polymers जो हैं, they can be called condensation polymers, while chain reaction polymers can be called addition polymers. So in the previous lecture we went through the mechanism of condensation polymers. Now today we are going through the mechanism of addition. So first we will go through the characteristics of condensation polymerization, which are that the molecules should have one or two functional groups like alcohol, amines or carboxylic acid groups. Second is that the reaction occurs between two similar or different functional groups or monomers. It can take place between a dimer and oligomer, one monomer and one dimer, or between a chain or another chain of polymers. And next is that smaller molecules usually combine to form large molecules. Mixed properties of both the molecules or functional groups are taken into consideration, and a linear polymer is obtained as the condensation product when both functional groups are difunctional. And next characteristics is that when one of the functional groups is tri or tetrafunctional, the polymer formed will be a cross-linked polymer having a three-dimensional network. And the average molecular weight decreases when monomers are added with one reactive groups. Therefore, the functionality of each monomer determines the average molecular weight and cross-link density. So these are some of the main characteristics of condensation. So during the process of polymeric chain growth, if there is only addition of one monomers without the loss of any small molecules, as we saw in the case of condensation polymerization, and the polymer is an exact multiple of the used monomer unit, then it is called addition polymerization. Example of addition polymers are polyethylene, polyvinyl chloride PVC, PP, polypropylene, etc. So now we go through the mechanism of addition polymerization. You see, addition polymerization proceeds through two types of mechanism. First is free radical mechanism and the second is ionic mechanism. And ionic mechanism can be of two types, cationic mechanism and anionic mechanism. So whether it is free radical or ionic mechanism, every polymerization reaction proceeds through three steps: chain initiation, chain propagation and chain. So now what is chain initiation? This is the first step of polymerization reaction where the initiator activates the monomer units, resulting in the formation of active center in monomer unit, as you can see here on the screen. I can be free radical or heat, pressure, catalyst, anyone. And the second step is chain propagation, which is the second step of polymerization reaction, where second, third, fourth and so on monomer units, they are added with activated monomer unit consecutively, resulting in the formation of a large chain. Here you can see this activated M to this activated species another monomer unit is being added in the consecutive steps and finally resulting in the formation of a polymer. The third step is chain termination, which is the third and the final step of polymerization reaction, where termination of active center is taking place by the following possible way, whether through the recombination of two smaller activated monomers, recombination of two larger activated polymeric chains, through the recombination of one smaller activated monomers with a large activated monomer, or through disproportion, that is the simultaneous oxidation and reduction of two activated. Now we will go through the free radical mechanism. So it is the way of polymerization where the initiator of the reaction is a free radical. Naam se hi it is become clear. This initiator free radical is produced by many ways, but one of the important way is the decomposition of the compound by sunlight, heat, catalyst, etc. As example, peroxide, hydroperoxide, per acids, they are very useful initiator in organic polymerization reaction. So here is a case of benzoyl peroxide. Decomposition of this benzoyl peroxide in the presence of sunlight or heat forms a free radical as initiator. Now the following three common steps of free radical polymerization reaction are as we went through. First is chain initiation, starting step. This is the first step of polymerization reaction where initiator is added to the monomer unit, resulting in the formation of free radical center in the monomer unit. This is the free radical chain initiation of vinyl chloride. Second step is, as you all know, chain propagation, which is the second step of polymerization reaction, where second, third, fourth, and so on monomer units are added with generated free radical monomer unit consecutively, resulting in the formation of a large chain. You can see here, this is the chain propagation step. Free radical chain propagation of vinyl chloride has been shown here in this slide. And the third step is chain termination, which is the final step of polymerization reaction, where termination of free radical after long propagation has taken place by the following possible ways. It can take place through the recombination of two smaller free radical, as I told you previously. So this is the free radical chain termination of vinyl chloride. So ignore this. Other important way of chain termination are, first is inhibitor reaction. The process of termination here is done by inhibitor, a compound which inhibits the growth of polymerization reaction by termination. This termination is done when inhibitor combines with generated free radical and give comparatively stable product. For example, oxygen, nitrobenzene, dinitrobenzene, and phenolic materials, they act as inhibitor in many organic polymerization reactions. And the examples of polymers formed by free radical mechanisms are polythene, polyethylene, polypropylene, styrene, styrene butadiene, etc. And now we will go through the ionic polymerization in details in the next lecture. So we can brush up here about this ionic polymerization. It is the way of polymerization where the initiator of the reaction is an ion, as the name indicates. So this initiator ion is formed from specific Lewis acid or base produced cation, that is carbonium ion, or anion carbene ion on the monomer unit. So in the next lecture we will cover up this ionic polymerization. So see you there in the